In this video, we're going to talk about triangle congruence. So to begin, we have to talk about congruence in a general sense. Congruence means same shape and size. So two figures are congruent if they have the same shape and size. We can figure out congruence through a series of rigid motions. So either one rigid motion or a combination of different rigid motions, because rigid motions demonstrate congruent figures. So for instance, a rigid motion is a motion I can make to a figure and not impact its shape or size. So a translation, reflection, or rotation, any of those isometries. Triangle congruence is defined as the corresponding angles and sides of two triangles must be congruent. So we can use rigid motions to prove that triangles are congruent. However, we'd have to have 6 different parts, 3 angles and 3 angles in each, and then 3 sides and 3 sides of each. So all of those elements get a little cumbersome. So we have what we call shortcuts, and in this case it's postulates and theorems. The first is the theorem, angle, angle, side. So angle, angle, side theorem tells us that if I have 2 angles and a side that is not contained between the 2 angles, so in the order angle, angle, side, then the triangles are congruent. Looking at this picture, I only have 1 angle. However, I know that vertical angles in triangles are congruent. And so I can state that triangle ABE is congruent to triangle DCE. And it's very important that we name these triangles correctly because of a theorem called corresponding parts of congruent triangles are congruent, or CPCTC. CPCTC tells us that the segments in our our segments or angles that correspond in triangles are congruent, and we can tell this by our congruent statements, the way we name triangles. So segment AB should be congruent to segment DC because it corresponds, which in this case it does. The next postulate we're looking at is side, angle, side. So looking at this picture, I can tell you that KM is a shared side, and since congruence is reflexive, if KM exists in both triangles, then it has to be congruent to itself. Well, we also have some given information that M is the perpendicular bisector of segment LJ. So if it's the perpendicular bisector, not only does it intersect at a 90-degree angle, it also intersects at the midpoint M, which then gives me congruent segments LM and MJ. And so by side, angle, side, I can state that triangle KML is congruent to triangle KMJ. And again, all my parts are corresponding in my congruent statement. The next postulate we'll look at is side, side, side congruence. Now, side, side, side congruence has 2 examples, and here's the reason. We'll start with this one. Again, a shared side, because congruence is reflexive, tells me that these triangles are congruent, and so I can go ahead and name them that ABC is congruent to CDB. Or I apologize, DCB. And notice how I caught my mistake is when I went over AB to BC, I went over 1 tick mark and then over the shared side. DCB, 1 tick mark and over the shared side, whereas the original thing I said was CDB. I know that those parts would not correspond because of the 2 congruence tick marks. And so when we're saying these, we'd also put by the postular theorem that it is congruent by, so I would put by side, 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 but since these are examples, I'm leaving them out. So in this situation, all I have is I have a shared side, an angle, and then a non-adjacent side. So in this case, we have side, side, angle. Side, side, angle. Now, it's important to note that side, side, angle does not exist. However, since this is a 90-degree angle, we know by Pythagorean theorem that c squared is equal to a squared plus b squared. So the remaining side has to be congruent to itself. Again, this is a special theorem called hypotenuse leg that we don't really get into, but we can use Pythagorean theorem to help us find another congruent side. So then we could state by side, side, side congruence with, and we would state Pythagorean theorem. And with that, I can conclude a congruent statement. Triangle ABD is congruent to triangle CBD. The last postulate we're going to look at is angle side angle. Again, a shared side, because congruence is reflexive. I can go ahead and state that triangle ABC is congruent to triangle CDA. It's important to note the difference between angle side, the theorem, and angle side angle, the postulate. Notice it's all about the placement of the side. In this situation, angle side, it is two angles with a side that is not between them. Whereas over here, I have two angles with a shared side between them, or a side between them. Using these different, the theorem and the postulates, we can prove congruence and then solve a couple of different problems in these congruent triangles. Thanks for watching.